In 2A, we're talking about problem solving. We're actually going to talk about problem solving when there are different units. So a few things, and I'm going to skip around a little bit on the notes, but when you are problem solving, the first thing you want to do is understand the problem. You have to know what it's asking for, right? And then we'll solve. And when you explain your results, you always want to keep in mind these things that I'm going to write down for you. Number one, it's do they make sense? Do the results make sense? Okay, and then next, is your answer reasonable? And then last, did you answer the question? These are the three things you want to be mindful of when we're providing our answer. So I'm going to move to where it says principles of unit analysis. And so today we're talking about units. Units are quantities or things that we're counting or measuring. So units we can say are what is being measured or counted. What is being measured or counted. Those are units. So we deal with units all the time. If you're baking, it's, a third of a cup or a tablespoon, a teaspoon. If you're measuring something, length, the inches, centimeter, feet, yards, these are all different kinds of units. And so with unit analysis, it is where we're solving problems involving different units. So we're solving problems involving different units. So we're going to work on doing that today. And the only thing I want to, you can ignore these bullet points. The only thing I want to make clear are there are key words as we're going through these word problems. You'll see there are key words that kind of give us clues as to what operation in math we should be doing. So in math, when I say operation here, there's 4 operations, which are addition, subtraction, multiplication, and division. And so I just want us to know these keywords. When you see per, like mile per hour, per means division. When you see the word of, that means multiplication. We're multiplying 2 things. Sometimes you see a hyphen also. Hyphen is like a dash line, right? That's not as common for us, but if you see the word of means multiplication. Per means division. If something is square, like you hear me say 2 squared, that means 2 times 2, right? Or 4. Square means raising something to the second power. And if something is cubed or cubic, that means you're raising it to the third power. So this is like 2 cubed. Means 2 times 2 times 2, which is the same thing as 8. So if you square something, you're raising it to an exponent of 2, second power. Cube means you're raising it to the third power. Let's look at these first few. I won't do all of them, but I'm going to pick a few good ones here. So it says, let's look at A. A warehouse is 60 yards long, 30 yards wide, and 6 yards high. What is the area of the warehouse floor? And then it says if the warehouse is filled to half its height with tightly packed boxes, I meant to put boxes, what is the volume of the boxes? So there's 2 questions being asked. The first one is, what is the area of the warehouse? So let's answer that first. How do we find area? I'm going to write that here. Area is equal to length times width. And we have those two values, right? A warehouse is 60 yards long, that's the length, and 30 yards wide, that's the width. So if I'm doing that, that is A for area equals, I'm going to do 60, I'm doing YD as an abbreviation for yards, times 30 yards. And you would get 60 times 30 is 1800. Now, notice what I'm doing to the units now. Say yards squared or square yards. That doesn't mean the 1800 is squared. It just means the units, the yards, is raised to the second power. Because that's what it means when you multiply the same thing by itself, yard times yard, that's yard squared. You'll notice that when we find area, always the units will be squared because of this reason. Okay, the next thing they ask is if the if the warehouse is filled to half its height with tightly packed boxes, what is the volume? So the volume of the boxes. The formula for volume, I'm going to put V for volume, is length times width times height. So I put LWH. It is length times width times height. So I do have the length and width, right? So that's 60 yards times 30 yards. Now pay close attention to the height. I know it says the height of the warehouse is 6 yards, but look what it says. If the warehouse is filled to half its height with tightly packed boxes, what is the volume of the boxes? I'm not looking for the volume of the warehouse. I'm looking for the volume of the boxes. So what is the height of the boxes? It says half the height of the warehouse, right? The warehouse is filled to half its height with tightly packed boxes. So if the warehouse is 6 yards high, the boxes are just half of that, 3 yards. Right? And now if we multiply that all together, we should get 5,400. And what is the units going to be here? Yard times yard times yard. That means I'm multiplying it 3 times. So that's yards cubed or cubic yards. Okay, let's look at this next one. C. A room has a rectangular floor that measures 24 feet by 16 feet and a flat 8-foot ceiling. What is the area of the floor and how much air does the room hold? Okay, so first question is, what is the area of the room? So we know how to find area, right? Area is equal to length times width. So it doesn't really state which one's length and which one's width, but it doesn't really matter. Area is 24 feet times 16 feet. So if you do that, if you multiply that, you should get 384. And what would the units be here? Feet squared. Remember, feet times feet is feet squared. So that's my area. And then it asks another question. It says, how much air does the room hold? So anything that's asking you for space filled in a 3-dimensional object, right? Like how much water is in your water bottle. Again, here, air in a room. Those are 3-dimensional objects and you're filling it. That's a volume question. They didn't say volume, but that's what they mean. So we know the formula for volume is length times width times height. They're looking for the volume of the room, and I've been given the dimensions. So that's 24 feet times 16 feet times 8 feet. And if you multiply that, you should get 3,072. And the units here would be feet cube or cubic feet. Let's look at the next one. A grain silo has a circular base with an area of 260 square feet and is 22 feet tall. What is the total volume? So just if you don't know, silo kind of looks like this. It's like a cylinder almost. Something like that. But you don't really have to know the shape. The volume formula, it's very direct, right? Volume is length times width times height. So they do give me the height, right? They say it's 22 feet tall, but I don't know the length and the width. But think about what they gave me. The area is 260 square feet. Isn't area length times width? That's the formula for area. So I'm just going to plug that in. Length times width is area, which they told me is 260 feet squared. And then height is 22 feet. So when you multiply 260 times 22, you get 5,720. And remember, for volume, your units is always cubed. Then I'm going to skip example 3. You don't have to worry about that. I want to look at example 4, and let's do a few of example 4. So it says we want to write out the 3 steps and answer the following questions. I'm not going to make you write out the 3 steps. I'm just going to show you how to answer it. So it says a hose fills a hot tub at a rate of 4.5 gallons per minute. How many minutes will it take to fill a 400-gallon hot tub? Okay, so notice in this problem, I need to solve this. They're giving me a rate. They're saying the hose fills the hot tub at a rate of 4.5 gallons per minute. Notice a key word, per. Per means division, right? We saw that in the table. So I'm going to write this as a fraction. Look how I write this. 4.5 gallon, I'm just going to abbreviate that, per minute. Per minute means per 1 minute. You don't have to write 1. It's understood that it is, but you can if you like. So that's my first step. I'm writing this as a fraction because I see the word per, that means division. And then I'm going to put an equal sign, and I'm going to try to write the rest as a fraction. It says, how many minutes? How many minutes means I don't know the minutes. How many minutes will it take to fill a 400-gallon hot tub? So I do know that I have a 400-gallon hot tub, and I'm trying to figure out how many minutes will it take to fill it. Notice that this fraction has the same units, gallons and minutes. So when I create my equal sign and my other fraction, make sure you align the units. If gallons are on the top of this fraction, I'm going to make sure I put gallons, in this case 400, on the top of my other fraction. And I'm putting X for the minutes because I don't know what the minutes are. That's what I'm being asked to find. And notice minutes are on the bottom of both my fractions. Now, to solve something like this, you do something called cross multiply. That means I multiply diagonally. It doesn't matter which direction you start. So for example, 4.5 times x, I'm going to multiply diagonally, and that's 4.5x equals multiply diagonally in the other direction. 1 times 400 is just 400. And so your goal is to solve for x. So I divide by 4.5 on both sides. So the 4.5 cancels there. And you get x equals, this turns out to be like 88.9. And we're talking about minutes. That is our answer. Next one. It says, suppose you earn $15.30 per hour, and you work 24 8-hour days in a month. How much do you earn in that month? So again, in this kind of question, I'm going to create a fraction with the first rate they give me, which is, this is how much I make per, you see the keyword there, per hour. So if I write that as a fraction, that's 15.30, I'm putting $ per 1 hour. That's my fraction. Set that equal to, now I'm creating my other fraction. Money goes on top, hour goes on bottom. So it says you work 24 8-hour days in a month. How much do you earn? So I'm looking for money, right? So I'm going to put an X on top. That's what I'm looking for. And as far as the hours go, I have to figure out, what does 24 8-hour days mean? How do I figure out how many hours that is? So that is 192. 24 days, 8-hour days, so 192. So that's the hours that go on the bottom, 192 hours. Now we do the same thing and we cross multiply. Again, it doesn't matter which direction you multiply first. 1 times x is x. And 15.30 times 192, I'll write that out. If you multiply that, you should get 2,937.6. And again, we're talking about dollars. Let's do one more. Let's look at C. So it says the city with the greatest population density is Manila in the Philippines. The city has a population of 1.8 million people 1.8 million people and an area of 16.6 square miles. What is its population density in units of people per square mile? Okay, so the one thing they give me is this. The population in Manila is 1.8 million people and an area of 16.6 square miles. So this is how I'm going to set that up. 1.8, I'm just going to abbreviate and put mil. 1.8 million people in 16.6 square miles means abbreviate miles, MI, and square it. So in that space of 16.6 square miles, 1.8 million people exist there. That's what that's saying. I wrote it as a fraction. Set that equal to, now I'm going to create another fraction. It says, what is the population density in units of people? So what is, I'm looking for the amount of people. Do you see that? What is, sorry guys, my pen stopped working. What is population density in units of people. So I'm looking for that. People were on top. Per square mile, meaning 1 square mile. 1 mile squared. Now I will go ahead and cross multiply. So again, multiply diagonally. That's 16.6x equals. Now here, I need you to know what 1.8 million means. 1.8 million means, I have to expand that. That's 1,800,000. That's what that means. I just abbreviated it there, but I have to show what that means. So 1.8 million times 1 is just 1,800,000. To solve for x, divide both sides by 16.6. And then if you do that, you should get 108,434 people. Then we're going to move on to example 6 next. Now for example 6, which is below, you'll need these conversions. Okay, so on your quizzes and definitely for this coming test, I want you guys to keep this handy for your quiz. This right here, you'll need these formulas. And I don't know if the quiz has it for every problem, but I'm okay with you using it. And on the test, I'm going to allow you guys to have a formula sheet and I'll upload that and I'll point it out when I've created it. but this test has a lot of formulas and like conversions for different units. I'm not expecting you to memorize that. I will give you those. I just want you to know how to use it. Okay, but this is good to keep for the test. I'm sorry, I said test, for the quiz right now. Okay. So let's look at some of these in example 6, unit conversions. So it says convert 4 feet to inches. So the first thing I want to do, I'm not solving anything here. Okay, so you don't have to put an equal sign and something's an X. You don't do that. This, you start with what you're given, 4 feet. And I'm going to multiply it by some conversion from 4 feet to inches. Look up here. There is a conversion from feet to inches, and it's 1 foot is 12 inches. So the way this is going to work is this. When I create this conversion, I put what I want to get rid of on the bottom, and I put the units I want to keep on top. Because look what happens now. The feet will cancel with the feet. And then I just multiply across. 12 times 4 is 48, and my answer is in inches. That's how you do that. So let's look at another one. Convert 16 feet to yards. So I start with what I'm given. I'm given 16 feet. And now let's look above for a conversion that has yards and feet. And that's right here. 1 yard is 3 feet. Or you can look at it the other way. 3 feet is 1 yard. So when I go here now, and I try to write this, I want feet to go on the bottom so they can cancel. So 3 feet is going to go on the bottom and 1 yard will go on top, because then feet will cancel, which gives my final answer in yards. And here, when you multiply across, that's 16 times 1, which is 16 over 3. And if you divide that, you should get like 5.3 yards. Let's look at C. This one you might know how to do without doing it in this way. You have 35 minutes. And you want to convert that to seconds. What's the relationship between minutes and seconds? So I'm going to put 1 minute on the bottom and 60 seconds on top so that minutes can cancel. And then I multiply 35 times 60, and I should get 2,100 seconds. Okay. Let's do a more challenging one. Let's look at H. This is probably a hard one. So we have 45,789 inches, and I want my final answer to be in miles. So you always start with what's given, inches. And now I need a conversion. So ideally, I'd look for a conversion between inches and miles. But if you look above where we were looking, there is none. And then they give me this. They're saying you can use these conversions. But notice there's no direct inches to miles. But I do see a chain of events that I can follow. If I read this backwards, it goes from inches, and I'll highlight here so you can see inches, to miles. If I look at it backwards, 12 inches is 1 foot. And if I have 3 feet, that's 1 yard. And if I have 1760 yards, that's 1 mile. So I'm going to go backwards in this, and I'm going to have to do a few conversions. And so I show you how to write that so that you're not doing it over and over again. So we start with inches, and then I'm going to use this first conversion that I just underlined. I'm putting inches on the bottom and 1 foot on the top. And then I'm going to multiply to that, and I'm going to use this conversion now. 3 feet on the bottom and 1 yard on the top. And then last, I'm going to use that conversion, which is 1760 yards and 1 mile on the top. Notice I wanted my final answer in miles. So look how this cancels. Inches cancel, feet will cancel, yards will cancel, and my final answer is in miles. So when you do this on the calculator, you do multiply across. That's 45,789 divided by whatever 12 times 3 times 1760 is. And you know your final answer will be in miles. So when I do that on the calculator, 45,789 divided by, if you multiply those numbers, you should get 63,360. And if you divide that, can anybody tell me what you get? I'm getting 0.72 miles. That is your final answer. Let's look at example 7. It says find a conversion factor between square feet and square inches. Okay, so let's look above for a second. There is a conversion between feet and inches. Feet and inches, which I don't believe I have it here. Oh yeah, there is. Feet and inches, sorry. But the problem is they ask for square feet and square inches. So that's not the same. I can't just say 1 foot is 12 inches. We want square feet. So I'm going to show you how to get that. If we know 1 foot is 12 inches, to get square feet and square inches, we're going to square this and square that, meaning raise it to the second power. When I do that, you square 1 squared is just 1, and you square the units. Here you're going to do 12 squared, which is 12 times 12, 144, and you also square the units. And that is my conversion now. 1 square foot is 144 square inches. And they said write it in 3 forms. This is one way to write it. Or you could write it like this, where we had it as a fraction, with the square feet on top and the square inches on the bottom. Or you can put it where the square inches are on the top and square feet is on the bottom. Those are all equivalent. Look at B. It says find the area in square feet of a rectangular yard that measures 20 yards by 12 yards. So they're asking for area. It says find the area. Now, the issue I see is that the area is, the dimensions they give are yards. But my final answer needs to be in square feet. So let's just go ahead and get started. We know area is length times width. And so I have length and width, that's 20 yards times 12 yards. And if I multiply that, that gives me 240, I'm going to write that here, 240 yards squared, right? Because it's yards times yards. The problem is they want it in feet squared or square feet. So let's look above. Is there some sort of relationship between yards and feet? And I see here 1 yard is 3 feet. We want everything to be squared. So I'm going to show you up here. If I want it to be squared, I square this and I square this. When I say squared, you have to square the number and the unit. the number and the unit. So in other words, 9 feet squared is 1 yard squared. That's the conversion I'm going to use here. So I'll write in here, remember 1 yard squared is 9 feet squared. We're going to use that. So to convert this, look at what I'm doing. I'm putting yards squared on the bottom and 9 feet squared on top. That way the yards squared will cancel. And if I do 240 times 9, I'm getting 2,160 square feet. That is my final answer. We are not going to do this currency conversion problems, so they have been removed from the homework and your quiz and your test, so you don't have to worry about this example. Then the last problem I actually want to do is just a gas mileage problem. It's the last example, example 10. So let's look at that. It says you plan to take a 2,000-mile trip in your car, which averages 32 miles per gallon. How many gallons of gasoline should you expect to use? So let's just answer that question first. So it says we have a 2,000-mile trip. So I'm going to put 2,000 miles. And the car, which averages 32 miles per gallon. Notice keyword again here, per. So I can write that as a fraction. We are looking for how many gallons of gas should you expect to use, right? If this is the rate, 32 miles per gallon, and I'm doing a 2,000-mile trip. So I want my answer to be in gallons. So I'm putting 32 miles on the bottom, 1 gallon on the top. This way the miles can cancel. And so multiplying across, that's 2,000 divided by 32, which is 62.5 gallons. That's how many gallons of gas I would use for that trip. Would a car that got half the gas mileage, meaning 16 miles per gallon, require twice as much gasoline for the same trip? So there's a way we can figure that out just mathematically, right? If I'm doing a 2,000-mile trip again, but this time, instead of 32 miles per gallon, it's saying this car takes half that gas mileage. That means 16 miles per 1 gallon. So let's see, let's do the math. Miles will cancel. So that's 2,000 divided by 16. And if we do that, we get 125 gallons. That is almost double, right? So will it require twice as much gasoline? Yes. This is almost double 62.5.